Hello guys, I'm Jinendra. We are going to discuss completely hands-on machine learning using this book. That the book name is Hands-on Machine Learning with Scikit-Learn and Pytorch. So if you bear up with me with this book, I know I'm pretty sure you can learn several major concepts and hands-on experience related to machine learning. So this book is written by Ariel Geran. So I'm using this book only for the academic purposes. While progressing this thing, I will skip only these unnecessary parts which is irrelevant for the academic purposes, and I'll uh, directly jump to the table of contents. Okay, so in the part one, we will be discussing about the fundamentals of machine learning. There we will learn what is machine learning, why we use machine learning, the examples of applications, types of machine learning systems like supervised, semi-supervised, unsupervised, and the other things. And also there are other methods of categorizing these machine learning methods like batch versus online learning, instant-based versus model-based learning. All of those things we will be discussing. And also the main challenges of machine learning: insufficient quantity of training data, non-representative training data, poor quality data, irrelevant features, overfitting, underfitting, deployment issues, and also testing and validation. And there we will be learning what are called hyperparameter tuning and model selection, data mismatch, and after that there will be an exercise in order to understand whether we have got the things. Okay, that is the part one. And in the part one, the first chapter, and the part one, the second chapter, is end-to-end machine learning method. Okay, end-to-end machine learning project. There we will be working with the real data set and understand what is the big picture and the big problem, what is that. And there we will be getting the data, how to get the data, run the code using Google Colab, and doing the changes, everything we will be discussing, and how to visualize data, and how do we use those data to machine learning algorithm, and how to select a training model. We are using a model, how to use uh, uh, how to select and train a model, and how to evaluate that one. All of those things we will be discussing under chapter 2. And the chapter 3 is basically classification, and there we will be using this MNIST data set and using how to make a binary classifier, the performance measures, the cross validation, and the confusion matrices, precision and recall, and the precision recall and trade-off, and the ROC curve. All of these performance measures we will be understand deeply using this third chapter. And then in the fourth chapter, we will be discussing the training models, and there are the regression models, linear, and the polynomial, and also the regularized of linear models like ridge, lasso, elastic, like that way. And after that, the logistic regression. We will be learning all of those things in under chapter 4. And the chapter 5, basically it is decision trees. We will be learning all the concepts which is underlined in this chapter. And number 6 is ensemble learning and random forests. And there we will be learning what is called the bagging techniques and also the boosting techniques. And chapter 7 is dimensionality reduction. And we will learn the curse of dimensionality, what is PCA, and also what is LLE. That means we learn all of those things and other dimensionality reduction techniques. And chapter 8 is unsupervised learning techniques. We will learn clustering, mainly the k-means clustering, and the Gaussian mixtures also we will learn. And in the part 2, we will learn about neural networks and deep learning. And there we will learn what is actually a perceptron, and the multilinear perceptron, and the learning rates and the things which is highlighted here. And chapter number 10, and we will build a neural network with Pytorch. And the Pytorch is the tool, a main tool what we are using here. So here we will build a neural network with Pytorch, and all the things which have been mentioned here we will learn. And number 11 is training deep neural network. So we will adapt to all of these things and we will learn the things there. And the number 12 is deep computer vision using convolutional neural networks, and we will learn the main theory and the associated hands-on experience related to computer vision here. And the next chapter we will learn about the RNN and CNN and basically. And next, the natural language processing with RNN and attention mechanism we will learn. Then the chapter 15 is transformer for natural language processing and chatbots. And there we will learn the GPT architectures, GPT 1, 2, and 3, and we will build the things from scratch. And then the vision and multimodal transformers also we will learn. And there we will learn about these things like the Dino and also VideoBird and the DALI and the Blip and Blip 2, those things. And chapter number 18, that is autoencoders, GANs and diffusion models also we will discuss. We will implement a stacked autoencoder using Pytorch, and these things, and also the convolutional autoencoders we will be learning. And chapter number 19 is reinforcement learning. There we will get the understanding of the reinforcement learning. Okay, those are the things what we are going to learn from this book. That means this is pretty related to all the things in machine learning and the industry related things. And we will while doing the things, what my technique is, I'm using my writing pad, explaining the things, explaining those things as thinking layers, and doing the codes step by step in a simple way in order to make you those things understand, right? So guys, the first the preface is not needed, I guess, because that is just the bluffing things. The prerequisites required for this thing is you want to have the Python programming. I will be creating a separate playlist in order to make you understand Python in as thinking layers. Okay, Python as thinking layers with so you can understand Python very well if you follow that playlist. Basically, the thing is, since there are a lot of AI generated tools involved, the guys, they are not willing to learn Python properly. Therefore, what is the main disadvantage is they cannot apply Python to their real projects. They do not know how to fix bugs. They do not know how to implement a project step by step without looking into any other resources. So if you follow the playlist that I am giving, that is my playlist, the playlist which I have prepared. So you can basically understand everything as thinking layers. So this roadmap also I don't want to explain. So actually now this book is previously written by using the TensorFlow tool, and TensorFlow is a Python framework. And now in this book, it is written in Pytorch. Pytorch is pretty flexible compared to TensorFlow, and many more researchers using that one. That is the difference here, because all the things what we are discussing here, we can do the implementation using TensorFlow as well. TensorFlow and Pytorch are two tools which are built on Python. So here he has mentioned I wrote 3 TensorFlow editions in this book, published by O'Reilly in 2017 and 2019 and 2022. TensorFlow was the leading deep learning library for many years, used internally by Google and therefore optimized for production at a scale. But Pytorch has gradually taken the lead, owing to its simplicity, flexibility, and openness. It now dominates the research papers and open source projects, which means that most new models are available in PyTorch first. As a result, the industry has also gradually shifted toward PyTorch. Okay, the reason is, guys, now there are different emerging trends are coming. The previously it was in the TensorFlow era. Now this is PyTorch era. Therefore, when industry use something more, something dominant than the others, we have to use that one, because that is called adapting to the industry psychology. So in recent years, Google has reduced its investments in TensorFlow. Now, Google has reduced their investments in TensorFlow and focus more on JAX. JAX is another tool. Excel, the deep learning library with a great mix of qualities for both research and production. However, its adoption is still low compared to PyTorch. Okay, this JAX, the adoption is less compared to the PyTorch. This is why I chose to use Pytorch this time around, O'Reilly, and I decided to make in the first edition of a new Pytorch series rather than the fourth edition of the original series. This leaves the door open for a Jack series or perhaps new edition for the TensorFlow series. Time will tell if either are needed, right? That means that is basically about this, the TensorFlow and Pytorch versions that he has used. Okay, then all those things are done. Now we can move to the fundamentals of machine learning. So guys, you have to stick with me. Don't skip anything. Just bear up the things what I'm telling. I will try to explain the concepts in a pretty way, which doesn't make you boring. So we'll move with this book. I will open my writing pad as well. I will enlarge this one for a while, but this is more right now. Okay, the machine learning landscape. Not so long ago, if you have picked up your phone and asked to, will highlight line say, not so long ago, if you had picked up your phone and asked it to tell you the way home, it would have ignored you. As an example, like pretty like years like 2000, right? The millennium, new millennium. If you had a phone in those era, okay, that is like those are not smartphones, right? From that phone, if you ask to show the way to go home, it will basically ignore you. And if somebody heard that you have asked that sort of question from the phone, they will think that you have gone crazy, right? Okay. But now, of course, the things have changed. The reason is the machine learning, guys. Okay. But machine learning is no longer science fiction. Billions of people use it every day, and the truth, it has actually been around for decades in some specialized applications, such as optical character recognition. Okay, guys, even though we thought like machine learning has evolved recently, machine learning here with us for decades. Like the one of the famous example is this optical character recognition that is here for decades. And also the first ML application that really became mainstream, improving the lives of hundreds of millions of people, discreetly took over the world back in 1990s. The spam filter. It is not exactly a self-aware robot, but it does technically qualify as machine learning. It has actually learned so well that you seldom need not to flag as email as spam or spam anymore. Right, guys? The first machine learning application that is well known and well spread, that is the email spam filter. Guys, it is a machine learning application. You do not want to flag as spam or ham. Okay, we will go to our writing pad. Okay, the first machine learning application, guys. Okay, the first ML application in 1990s. That is what? Spam filter. There, what you can do, you can classify your emails as spam and ham. Ham means good emails. So you want to have the correct emails. Okay, so this machine learning, what it has done, it will read thousands or 10,000 or more past emails. Okay, past emails, and identify patterns. Okay, identify patterns. That means learning. Okay, learning. Identify patterns, and by using those data, because it has learned the things, it can classify as this email as a spam and the other email as ham or whatever. Okay, spam or ham, like that way it can done. So that is machine learning. Okay, that is machine learning. Again, we'll move to the book. So then, thanks to big data, hardware improvements, and few algorithmic innovations, hundreds of ML applications followed and now quietly power hundreds of products and features that you use regularly. Okay, guys, now we know that the big data is evolved. Okay, big data is evolved. Okay, when considering big data, okay, what is called big data, guys? Big data. Big data. Big data is the data which cannot be processed. Which cannot be processed using traditional processing techniques. Like we normally the data we will store them in traditional databases like SQL databases. Okay, but these SQL databases cannot handle large number of data. So you need different techniques like Spark, Hadoop, and new techniques we will be using for that one. So that is basically big data. We will come to this stage in the later stage of the book. Okay, so then hardware improvements. Hardware improvements means nowadays we will be using GPUs and few algorithmic innovations. Now the algorithms have been changed a lot in these days. Hundreds of ML applications followed and now quietly power hundreds of products and features that you use regularly. Those examples are voice prompts, automatic translation, image search, product recommendations, and many more. And finally came ChatGPT, Gemini, formerly Bard. Okay, can you remember that Gemini has previously named it as Bard, Google Bard? Now it is Google Gemini, right? Okay. Claude, Perplexity, and many other chatbots. AI is no longer just powering services in the background. It is the service itself. Now AI is a service, guys. Okay, AI is a service. So you want to understand this AI. If you want to understand AI, you want to understand the heart of it. That heart is the machine learning. Where does machine learning start and where does it end? What exactly does it mean for a machine to learn something? Okay, where does machine learning start and where does it end? Okay, from where this machine learning starts and how it will be end? Okay, what exactly does it mean for a machine to learn something? What do you mean by machine is learning something? Okay, if I download a copy of all Wikipedia articles, has my computer really learned something? Just imagine you have downloaded some Wikipedia articles. Okay, has your computer learned something by that? No, right? Is it suddenly smarter? No. In this chapter, I will start by clarifying what machine learning is and why you may want to use it. Okay. Then before we set out to explore the machine learning continent, we will take a look at the map and learn about the main regions and the most notable landmarks. Supervised versus unsupervised learning, supervised versus unsupervised learning and their variant, online versus batch learning, instant-based versus model-based learning. These are the main categories of machine learning. That means you can categorize into several forms, and these are the main things. Okay, one thing is supervised versus unsupervised learning. Okay, and there are few other variants of that one. Okay, the mainly supervised and unsupervised. Then there is another one called online versus batch learning. Okay, we have to, what is that? Then instant based versus model based learning. Instant based versus model based learning. Okay, then after learning them, you can understand the workflow of a typical machine learning project. Okay, then discuss the challenges that you are facing in a typical machine learning project. Okay. Okay. This chapter introduces a lot of fundamental concepts and jargon that every data scientist should know by heart. That means here you are learning several fundamental concepts, guys, and a lot of technical jargons. Those are the things what a typical data scientist should know. Okay, it will be a high level overview, and this chapter it is just a high level overview. It's the only chapter without much code, and this is the guys. This is the only chapter without a coding. You don't want to code in this chapter. A little bit like the conceptual things, and but don't feel bored. We will finish this chapter and we will be moving to the next chapter, right? But you want to understand all these fundamental things before move to the chapter 2. So if you are already familiar with machine learning basics, you may want to skip directly to chapter 2. If you are not sure, try to answer all these questions. But I am pretty sure you have to learn everything. Okay, so bear with me, and then we'll move to the chapter 2. Okay, what is machine learning? What is machine learning? Okay, there are several definitions for machine learning. Okay, machine learning is the science of programming. Machine learning is the science or art of the programming computers so they can learn from data. That means machine learning is the science of programming computers. Okay, so they can learn from data. Okay, the machine learning is the science or art of programming computers, which then what allow the machines to learn from data. Okay, we'll write that definition. Okay, that's the way we are understanding. ML definition 1. ML definition 1. Machine learning is the science or art of programming computers, which then which they can learn from data. That means this allows the machines to learn from data. Okay, so machine learning is the science which allows the machine to learn from data. That is the simple thing. Okay, machine learning is the science of programming which allows machines to learn from data. Okay, that is the first definition. More back. That definition is given by Arthur Samuel in 1959. Pretty old. And then there is a more engineering oriented one. Okay, the engineering oriented one, and it has been given by Tom Mitchell in 1997. A computer program is said to learn from experience E with respect to some task T and some performance measure P if its performance on T as measured by P improves with experience E. Oh, what does it mean? Okay, don't be confused with the engineering definitions are like that, guys. But don't be confused. Okay, how do we understand this properly? A computer program is said to learn from experience E. Okay, we'll write those symbols first. E is the first thing. E experience. Okay, I will write the things what the thing is given. And there is T. T is the task. And what is the other one? P. P is the performance. Okay, guys. What do you call this experience, guys? The experience is coming from the things what we are learning. Learning means it is the data. The experience means data. Experience means data. Task means the given task, the given work. Given work. Performance means how successful is that? Okay, we'll get an example. Filter. Spam filter. Okay. Okay. What is the experience, guys? You are provided labeled data. Label means you already know what are spam and what are ham, like 10,000 emails. Spam and ham. You know this. Okay, that is called the experience. Okay, you are provided this data set, which is the label data sets of 10,000 data. And what is your task? What is your task, guys? The task is you want to classify them as correctly as spam and ham. That is the thing you want to do. That is your task. Task is classifying. Task is what? Classifying spam and ham. What is the performance means? Performance means how successfully it has classified. That means among the given emails, if new data is provided, suppose now new emails, hundreds of new emails are provided, it's correctly classified like spam, ham, spam and ham, or there are 85 of them are spam. Just imagine, and you have correctly identified them as the 85 among the hundreds of spam emails. Okay, just imagine, among the hundreds of spam emails, you have correctly identified 85 of them as spam, because there are another 15 you couldn't identify. Okay, So your accuracy or the performance is 85%. Okay, 85%. Okay, that is called the performance. Okay, performance means how successfully you have identified whether the given data is in this way or that way. Okay, so I think it is clear about the experience. Experience means the provided data, uh, and the task means what you want to do, and the performance is how successfully you are. Okay, okay, then what does that definition says? When your experience is more, that means when you provided more data, when you provided more data, then your performance will increase. Is that correct? When you like, instead of 10,000 emails, you are providing 1 lakh of emails, which the label data set. That means you are learning more. When you learn more, your performance will increase. That means your ability to classify them as spam and ham will be increased. Okay, that is that engineering definition. I think you understood that one. Okay. Okay. Your spam filter is a machine learning program. Your spam filter is a machine learning program that given examples of spam emails. That means that spam emails is flagged by users, and examples of regular emails like non-spam, also called as ham, can learn to flag spam. Okay, uh, because while understanding about these ham emails, you can understand what are those spam emails. The examples that the system used to learn are called training set. Okay, very good thing. Okay, the examples that the system used to learn. Okay, we'll move to the writing pad again. The examples, training data. Examples that the system used to learn. The examples that the system used to learn. Okay. The examples that the system used to learn are called training set. Each training example is called a training instance or sample. Each training example, that means just one email. Each training example is called training instance. Training instance. That means each training example, or we call it as a sample. Okay. Each training instance, each training example is called as training instance. The part of a machine learning system that learns and makes predictions is called model. Wow. The part of a machine learning system that learns to make predictions is called a model. The part of a machine learning system that learns and makes predictions. I will erase this one. Or we can basically use this one, right? Model. Model is a part of the machine learning system which learn and make predictions is called a model. A model. The neural networks, those are called as model. Neural networks and random forests are examples of models. In this case, the task T is to flag spam for new emails. The task is what? You want to flag spam for new emails. The experience E is the training data. experience E is the training data. Training data means the examples that it is provided. And the performance measure P needs to be defined. For example, you can use the ratio of correctly classified emails. Okay, because this performance is something that we are defining. Okay, that definitions you can give it as a ratio or the ratio of accuracy, like that. You can use the ratio of correctly classified emails. This particular performance measure is called accuracy. Okay, the ratio of corrected classified emails. Okay, since it is used with the corrected classified emails, we call it as the accuracy, and it is often used in classification tasks. Oh, okay, one a bigger thing we have understood here, that is that. Okay, the formal definition I will give later. The accuracy is a metric. It is a performance metrics. And this is used only for classification. You will understand in machine learning, basically it will be divided into two parts. Okay, you will learn this. These things are regression. Okay, but before moving to this, the ML field mainly divided into supervised, unsupervised, but we'll skip this unsupervised for a while, and we think about the supervised learning. And this supervised learning, there are two cases, two categories. The one thing is the regression. The other thing is the classification. Now, in all cases, we need to have some kind of metrics to evaluate. Now, I told this accuracy also a metric, and that metric is coming under classification only. Accuracy. Okay, this accuracy metrics will be coming under classification in supervised learning. You will be learning more things later. Okay, still we are in the introduction, right? Okay. Right. If you just download a copy of Wikipedia articles, your computer has a lot more data. You have a lot more data, but it is not suddenly better at any task. If you download articles, that means you have data. Okay. Even though you have data, you have not assigned a task, right? But it is not suddenly better at any task. This is not machine learning. Okay. Then we'll move to the things. Why this machine learning? Why you use machine learning? Consider how you would write a spam filter using traditional programming techniques. Just imagine you want to write a spam filter just using your traditional rule-based software engineering techniques, like if-else statements, like that way. First you would examine what spam typically look like. You might notice that some words or phrases, like when why you are thinking that this email is spam. Okay, you can just go to the spam folder and identify what are spam emails are. Okay, this the Gmail, it uses what we call the spam filter, which is machine learning based thing. Okay, and according to the earlier provided data, it will be understanding what are the behavioral types of this spam emails, and according to that it will classify. But there you can see some kind of non-professional things like the for you. Okay, this is some kind of spam email. Okay, for you. Instead of writing for, this thing for you. Then credit card. Okay, because spammers are writing always this the word used in this, like spammers are wanted to get you informed some kind of this the financial things like credit card, something like that. And also the free. Okay, like the annoying advertisements always coming with the word free. And amazing, like always, like the more non-realistic way, the amazing, wonderful, like that way. Okay, then they tend to come up a lot in the project subject line. Then in the subject line, these type of things are coming to in order to attract the user, right? uh, Perhaps you would also notice few other patterns in the sender's name. Okay, perhaps you would also notice few other patterns in the sender's names, the email's body, and the other parts of the email. You would write a detection algorithm. Okay, now in the traditional uh, rule-based learning, you would write a detection algorithm for each of the patterns that you noticed, and your program would flag emails as spam if a number of those patterns were detected. Okay. Uh, okay. What are those the patterns that you have noticed? Those are the patterns which I have mentioned here in the subject line. You would test your program and repeat steps 1 and 2 until it was good enough to launch. Like that. Study the problem. So the first is to study the problem. Then after studying the problem, you can write the rules. If there is a for you, okay, make it classify as spam. Otherwise, ham. Okay, write rules. Okay, write rules and then evaluate, then launch. Okay, then in the evaluation, what will happen? If you understand some kind of errors, okay, if it is not if there is a ham email, you have made it as spam, or if it is a spam email, you have made it as ham. Then you have analyzed the errors, and again you can study the problem and again write the rules. Like that, this will be repeating the things. Okay, that is the traditional approach. Okay, now in this case, what will happen? You have to write large number of rules whenever the spammers write some kind of things. Okay, this is therefore difficult. Like that way, just imagine if the uh, spammer has written, instead of this for, okay, he has put like the word for, okay, and make it something capital F, capitalized for and you. Okay, then you have to write again another rule for that one. That means there are several plenty of rules you want to write. Okay, in contrast, a spam filter based on machine learning techniques automatically learns which words and phrases are good predictors. But in machine learning, you do not want to give anything like that. The rules, you don't want to give anything. What you have provided, what you want to provide the data. You want to basically give the label data. These are the spam emails. Okay, you are giving lot of data. Then what will happen? It will learn by itself. Okay. In contrast, a spam filter based on machine learning techniques automatically learns which words and phrases are good predictors of spam by detecting unusually frequent patterns of words in spam emails compared to the ham examples. Okay, we'll move to the figure 1-2. The figure 1-2 here in the machine learning, what will happen? It will study the program, study the problem, okay, and it will train a machine learning model. Okay, study the machine learning model, and then it evaluating the things. After evaluating, it will be launching. Okay, and also in the evaluation, if something goes wrong, it will I understand or analyze the errors, and again study problem and going like that way. Okay, this is the machine learning approach. Okay, here we are, what we are giving here, we are data. We are providing the data and we are training. Okay, uh, in a spam filter based on machine spam unusual patterns. Okay, anomalous behaviors are available, or the unusual normally compared to the common way, there are some unusual patterns available in the spam examples compared to the ham examples. So then this program is shorter than the things, but because we don't want to provide any rules. Okay, what if spammers notice that all their emails containing for you are blocked? Means now in our rule, this for you, according to the program, it will be blocked. Then what will happen? Then the spammers will start by writing, instead of this for, as the way I told, they will use the word for and you. Okay, instead. Now what do you want to do? A spam filter used in traditional programming technique would need to be updated to flag for you. Now you want to make the rule, and you want to update the rule for this thing as well. Okay, if spammers keep working around your spam filter like that, if the spammers also, they are understanding what goes wrong, and they will update the things according to that. What you want to do, if you are using the rule-based learning, the rule-based techniques, what we have to use, you want to update the things according to that. If spammers keep working around your spam filter, you will need to keep writing new rules forever. Okay, that is pretty difficult, and you can't actually do like that way. In contrast, a spam filter based on machine learning techniques automatically notices that for you has become unusual, frequent in spam flagged by users. Now we are providing the data. Now when we are providing the data, the machine learning technique, it will be identify this for you also showing in the what we call this the spam emails. So it will be understanding it automatically, and it starts flagging them without your intervention. Okay, so while training the model, they evaluate and launching, and then after launching, you can update the things. Okay, update the things means you will be according to the new data will be trained. Okay, so it will be going like that way. Another area where machine learning shines, is for problems that either are too complex for traditional approaches or have no known algorithm. That means we are discussing why machine learning. Okay, now there one thing we have understand, what when there is a cases, we cannot write lot of rules, we have to use machine learning. Okay, that is like the spam filter. The another area where machine learning shines is for problems that either are too complex for traditional approaches or have no known algorithm. If there is no known algorithm for certain tasks, for example, consider speech recognition. Say you want to start simple and write a program capable of distinguishing the words 1 and 2. You might notice that the word 2 starts with a high pitch sound, So you could hard code an algorithm that measures high pitch sound intensity and use that to distinguish ones and twos. But obviously, these techniques will not scale to thousands of words spoken by millions of very different people in noisy environments and in dozens of languages. The best solution, at least today, is to write an algorithm that learns by itself, given many examples recording for each word. As an example, if you want to identify the high pitch and the low pitch in the speech recognition, uh, the rule-based software engineering techniques cannot be used. The problem is it will be differ from people to people, from person to person, and from language to language it will differ. So giving like instructions, like rule instructions for that is utterly difficult. So what you can do is you can give the recordings of millions of people or the thousands of people and make them make our machine learning program to understand the things. That means then it will be classifying as what we call high pitch and low pitch. Then finally, machine learning can help human to learn. Finally, machine learning can help human to learn. ML models can be inspected to see what they have learned. Although for some models, this can be tricky. For instance, once a spam filter has been trained and on enough spam, it can easily be inspected to reveal the list of words and combination of words that it believes are the best predictors of spam. Sometimes they will unsuspected corrections of new trends and thereby lead to a better understanding of the problem. Digging into large amounts of data to discover hidden patterns is called data mining, and machine learning excels it. Okay, what does it mean? This machine learning can be used for data mining. That means it allows the humans to learn the things which the patterns which is not already discovered. Okay, uh, as an example, the spam filter had been trained on a sufficient number of spam. Okay, then it can be easily inspected to reveal the list of words and combinations of words that it is believes are the best predictors of spam. Okay, according to that learning thing, it can showcase, okay, these are the best predictors of spam. Sometimes this will reveal unsuspected correlations of new trends, and also it will reveal some of the correlations of new trends. Okay, then and thereby after that you can understand the better about the problem. So like that you can understand the better things. You can understand several things that you have not already known using this machine learning. So what you can do is to study the problem and train the machine learning model according to that. Then you are providing the solution. Then you are inspecting that solution. Okay, you are discovering the patterns. You are inspecting the solutions. You will be identifying some patterns. While understanding the pattern, that means you will be understanding you will understanding better about the problem. Okay, if you understand better about the problem, you can repeat it. Okay, again go to the first step and move like that way. Okay, when there are lots of data, you can do like that way. Study the problem, train ML model, providing solution. After providing solutions, you can inspect the solution. You can go to the solution and check, and by that solution you will be understanding what is that the insights of that one. Okay, then understanding better about the problem, and you can repeat if you need. Okay, this is called machine learning approach for data mining. Okay, then to summarize, machine learning is great for what, guys? problems for which existing solutions require a lot of work and maintenance. Problems for which existing solutions require a lot of work and maintenance is needed, such as long list of rules. As an example, the spam filter, you have to write lot of rules for that one. Okay, so using machine learning approach, you can make it simplified. You can just provide the data set, and there can be some complex problem for which using a traditional approach yields no good solution. As an example, voice recognition. It is very complicated. Okay, you cannot identify the things. There is no learning algorithm for that one, non-algorithm for that one. Okay, so in that cases, machine learning can be used. Then the fluctuating environments. Okay, the next case is the fluctuating environments. The machine learning systems can be easily retrained on new data. That means if the things are changing, like stock prices, these are changing frequently. In that cases, you can you want to have a retraining. Okay, this retraining can be easily done using machine learning. So in that cases, you can use machine learning. Getting insights about complex problems and large amount of data. That means machine learning can be used for data mining. Okay, so whenever the problem is needed very high number of rules, you can use machine learning. And when there is a problem that you do not have already a solution or algorithm, you can use machine learning. And when there is a fluctuating environment, the things are frequently changing, like stock prices, you can use machine learning. And machine learning can be used to get insights like data mining. Okay, those are the 4 things that the machine learning can be used. Okay, we'll move to the examples of examples of applications in the next video.